In last two videos, I had discussed mesh analysis where we had applied Kirchhoff's voltage law for analyzing the circuits. In that two videos, we had discussed their concept as well as we have solved the numericals. There was one special case as well when we had a current source in the outer branch where we have seen that we can have the answer of that current directly. In this video, I will move on to the next special case, that is when we have current source common to two different meshes. So where we need to apply concept of supermesh. So basically we are studying the supermesh analysis in this video. To understand the concept of supermesh, let's consider that we have a circuit where we have a current source present between two meshes like this current source. So first step over here is same as mesh analysis, that we need to identify that how many meshes are there. First, second, third. So we have three meshes. We have identified that we have three meshes. So the next step is we need to assign mesh current to each mesh. Now that's your choice that whether you want to assign them in clockwise direction or in anti-clockwise direction. I am considering all of them in clockwise direction. The first mesh current as Ix, second one Iy, third one Iz. Once we have the mesh currents assigned, then we need to apply KVL to each mesh. Now if I start with mesh 1, we know that this is a voltage source. We can write the voltage of the source. We can mark the polarity of voltage drop across the resistance as per the direction of current in first mesh, that is current Ix. We can write this drop. But when we come to this current source I1, we don't know that what is the voltage across this source. So here the problem arises that we can't write the voltage drop across this source. So KVL is not applicable. Similarly, for this mesh 2, we can write the voltage drop across resistance R2. We can write the voltage drop across resistance R3. But when we come across this current source I1, again we don't know what is the voltage across this. So the same problem appears in mesh 2 as well, that we can't apply KVL. In this case, what is done, the two meshes which are having a current source in common, like over here mesh 1 and mesh 2, they are combined together to make a super mesh. So what we say, that combine mesh 1 and 2, and that will result in super mesh. And then we have to apply KVL to this super mesh. Now when we apply KVL to supermesh, starting from the source V1, as negative sign is coming first, so minus V1, then drop across R1 is Ix into R1, positive sign is coming first, so plus I1 into, so R1 into Ix, then drop across R2. Now when we move to second mesh, we have to consider the current of second mesh, that is current Iy. So drop across R2 is R2 into Iy, positive sign is coming first, so plus R2 into Iy, then drop across R3, positive sign, plus R3 into the resultant current through this R3 in direction of Iy. So that will be Iy minus Iz equal to 0. This is the equation which we get by applying KVL. Second is the constraint equation. That constraint is imposed by this branch. Why? Because we have a current source in this branch, and we know that current source is a source which supplies constant current. So the current in this branch, that will remain I1 in upward direction. So with the resultant current in terms of mesh currents, that should be equal to I1 and in same direction. Iy is in same direction, Ix is in opposite direction. So resultant current is Iy minus Ix in same direction with the I1. So this is the constraint equation. So now we got two equations from these two meshes. First is by applying KVL. Second is the constraint equation. Third equation we can get from mesh 3. We will assign the polarity of voltage drop across each resistance across R4 positive negative as per the direction of Iz. Similarly across R3 positive negative as per the direction of current Iz. So now we apply the KVL to mesh 3 starting from drop across R4 into Iz plus V2 plus R3 into Iz minus Iy, that is the resultant current through R3 in direction of Iz. So now we will have these three equations, and using these three equations we can find out three different mesh currents. So basically, what is supermesh? Supermesh is combination of two meshes which are having a current source in common. So you need to keep in mind that only those two meshes are combined together which are having a current source in common, like over here these two meshes. We can't combine it with the third mesh, because if we combine it with third mesh, that will result in a loop. We can have also the case when we are having three meshes, like if we are having the same circuit with a little change. Now what is that little change? That we are having another current source which is now common to mesh 2 and 3 as well. Now we are having two sources, two current sources and two voltage sources. We have to solve this circuit using mesh analysis. So first step is we need to identify that how many meshes are there. We have three meshes. The next step is we need to assign the mesh currents. I'm assigning first current as Ix, second mesh current as Iy, third mesh current as Iz. Now if we want to apply KVL to mesh 1, we have a problem across this branch. Because we have a current source present in this branch, we can't write the voltage across this. So same problem is there with mesh 2 and with mesh 3 as well. Now in this case, how we need to combine the meshes together? Mesh 1, 2 and 3, they are combined all together to make a super mesh, and we will have two constraint equations. in comparison to the first case where we have combined two meshes together, first mesh and second mesh. We had one equation by applying KVL and second one is the constraint equation. In this circuit, we will have one equation by applying KVL and we will have two constraint equations. So as per the direction of currents, each mesh current Ix, Iy and Iz, we will assign the polarity of voltage drop across each resistance. Plus minus, plus minus, plus minus. And then we apply KVL to mesh 1, 2 and mesh 3, making a super mesh. Means KVL is applied to the super mesh. Apply KVL to super mesh starting from V1 minus V1 plus R1 into Ix plus R2 into Iy plus R3 into Iz plus V2 equal to 0. So this is the one equation which we get by applying KVL. Then we will have two more equations, that will be the constraint equations. Now instead of having just one equation as constraint equation, we will have two constraint equations. First constraint is imposed by this branch, that the current in this branch is in downward direction, that is equal to I1. So we need to find out this I1 in terms of mesh currents Ix, Iy and Iz, and it should be in downward direction. So in downward direction, Ix, Iy is in the upward direction. So the constraint equation is I1 is equal to Ix minus Iy. And second constraint equation is from this branch where the resultant current is in upward direction equal to I2. So the mesh current which is in upward direction, that is Iz. Y is in downward direction. So next constraint equation is I2 is equals to Iz minus Iy. So now we have these three equations available with us. For three unknowns, we can solve them all together and we can analyze the circuits even if we are having current source present between any two branches by applying KVL. In next video, I will solve the numericals where we have different types of super meshes, means we will have the current sources common between any two meshes or between three meshes.